Hi class, this is Coach Riza. In this video, we're going to talk about stoichiometry, the mole concept. Stoichiometry is the quantitative relation between the number of moles and therefore mass of various products and reactants in a chemical reaction. In this lesson, we're going to talk about the mole concept. Let's talk about first Avogadro's number. In the SI system, the mole, with a unit of mol, is defined as the amount of substance containing the same numbers of particles as their atoms, exactly 12 grams of carbon of 12 isotopes. So it means that 1 mole of a substance is equivalent to the Avogadro's number of particles, which is 6.02214076 times 10 raised to 23, or just simply 6.02 times 10 raised to 23. So that is the value for the Avogadro's number. Again, 1 mole of a substance is equivalent to the Avogadro's number of particles, the number of particles that is present in our 1 mole of a substance. So based from the definition of Avogadro's number, 1 mole of an element is numerically equal to its atomic mass unit. Number 2, 1 mole of an element contains 6.02 times 10 raised to 23 atoms. So, ibig sabihin, yung 1 mole ng isang element, nagko-contain siya ng Avogadro's number in atoms. So, for example, we have 1 mole hydrogen. It's equivalent to 6.02 times 10 raised to 23 hydrogen atoms. Number 3, 1 mole of molecular compound contains 6.02 times 10 raised to 23 molecules. Again, no, ang isang mole daw ng isang compound, nagko-contain siya ng Avogadro's number of molecules, no? Yung number of particles natin, no, in Avogadro's number. So, for example, we have 1 mole of water, so it's equivalent to 6.02 times 10 raised to 23 water molecules. And for number 4, 1 mole of ionic compound contains 6.02 times 10 raised to 23 cations and anions. So, ibig sabihin, ang isang mole ng isang ionic compound, nagko-contain siya ng Avogadro's number ng cations and Avogadro's number ng anions. As we can see here in this example, 1 mole of sodium chloride is equals to 6.02 times 10 raised to 23 sodium ion. And 1 mole of sodium chloride is equivalent to 6.02 times 10 raised to 23 chlorine ions. Next is molar mass. Molar mass is the mass in grams of 1 mole of a substance. So the unit for molar mass is grams per mole. Again, it is the mass in grams of 1 mole of a substance. So, yung isang mole pala ng isang substance ay merong bigat, no, in terms of grams, no, may mass siya. Okay, so yun nga po si molar mass. Now, how do we find, no, the molar mass, no, of an element or a compound? We have here an example. We have water and galactose. No? We have 2 examples here. So, let's find out how are we going to compute the molar mass. In computing the molar mass, class, the things that we need to find in our periodic table of elements is their atomic mass and the number of elements present in the compound. So basically, that is the formula for molar mass. So for water, we have H2O. So we have hydrogen and oxygen. And for this case, you just have to write the atomic weight or atomic mass. And you have to times that to the number of element that is present. So for hydrogen, we have 2. For oxygen, we have 1. So as you can see here, we have the values. I-add lang natin yon and we will get the molar mass. If the answer is a bit long, you can round it off until 2 decimal place or a whole number. So it's okay. It's still the same. So molar mass for water, it's 18.02 grams per mole. Same goes with galactose. Again, just write the elements present in the compound. So for galactose, it's a sugar. It's 6 it's C6H12O6. So we have carbon, hydrogen, and oxygen. And just write again the atomic mass of each element and then times the number of element present. So for carbon we have 6, hydrogen we have 12, and oxygen we have 6. And the values, just add all the values and you will get the molar mass. So the molar mass of galactose is 180.16 grams per mole, or you can round it off to a whole number, so 180 grams per mole. So that's how you compute for the molar mass. Now let's try to find the molar mass. So try it on your own. Use your calculator. How are you going to compute the molar mass? So we have three given samples here. We have sulfuric acid, salt, and zinc. So as you can see, it's already laid out the elements, their atomic masses times the number of the element present in the compound, and you're just going to add the values. Now on your own, try to compute for the molar mass. Okay, so let's start with sulfuric acid. What is your answer? Let's check if you got the same result. So for sulfuric acid, the molar mass is 98.08 grams per mole, or just simply 98 grams per mole. Okay, so next we have salt, sodium chloride. So again, for the molar mass of sodium chloride, we have 58.44 grams per mole, or just simply write 58 grams per mole. The last one is zinc. Zinc is an element. Okay? So obviously, zinc, nag-iisa lang siya. So we're just going to use the atomic mass. So the atomic mass is 65.409. So just simply write 65.409 grams per mole. So that's how you find the molar mass. Did you get the same result? Okay, so let's move on to the next slide. The next topic is about mole. Mole is represented by letter N, small letter n, which is equals to MOL. So MOL is the unit for mole. You can write MOLE or just simply write MOL. Okay, so again, mole is the amount of substance. We can calculate the mole and the mass of a substance using the molar mass. So again, mole is the amount of the substance. So how are we going to compute for mole, or the moles of a substance? So we have here an example. How many moles are present? In letter A, we have 5.2 grams of aluminum. And letter B, we have 180 grams of water. Okay, so again, as I have said, we can calculate for the mole using the mass and the molar mass. So with the given mass and the molar mass, for number 1, the molar mass of aluminum is 27 grams per mole. We can now compute for the mole. So using the molar mass as our conversion factor. So we have 5.2 grams of the given aluminum times, for every 1 mole, we have 27 grams of aluminum. So cancel si grams, and the mole is 0.19 moles. So ibig sabihin nun, class, there is 0.19 moles sa 5.2 grams. So yun lang yung dami ng moles na present sa 5.2 grams. Okay? So next, for the water, sample number 2, we have its molar mass of 18.02 grams per mole. So using the molar mass, compute na natin siya with the mass. So 180 grams times 1 mole over 18.02 grams. Makakancel si grams. And we have 10 moles. So ibig sabihin ng class, there are 10 moles present sa 180 grams of water. So that's how you compute for the mole. Again, the mole is the amount of substance and it varies depende kung gaano karami yung substance. So using the mass and the molar mass, we can compute for the mole. So the next part is calculating naman the mass using the mole of a substance and the molar mass. So as I have said, si mole, mass, molar mass, they are connected. So kaya naman ginagamit natin sila para ma-compute natin yung mole and mass using the molar mass. Now for this case, we're going to compute the mass. So using naman yung mole and the molar mass. So kabaliktaran naman. Kung kanina si mole yung hinanap using the mass and the molar mass, ngayon naman si mass ang hahanapin using the mole and the molar mass. So we have here examples. What is the mass of letter A? 5 mole of calcium hydroxide. And letter B, 2 moles of aluminum. So again, given yung mole, and then for this case, pinigay na din si molar mass. So let's compute first number 1. So we have here the molar mass of calcium hydroxide, which is 74 grams per mole. So using the mole and the molar mass, let's compute for the mass. 5 mole times for every 74 grams, there is 1 mole. Cancel si mole. So the answer is the mass of the calcium hydroxide is 370 grams. Okay, next we have number 2. The molar mass of aluminum is 27 grams per mole. So sabi niya dito, yung given 2 moles. So using the 2 moles times the molar mass, so of 27 grams over 1 mole, cancel si mole, we have 54 grams. So that's how you compute for the mass using the mole and the molar mass. So let's have a recap of Avogadro's number. So based from the definition, let's focus on number 2 and number 3. So sabi nga uli, 1 mole of an element contains the Avogadro's number in atoms. Same goes with 1 mole of molecular compound. It contains yung 6.02 times 10 raised to 23 molecules. The Avogadro's number and molar mass are important to enable conversion between mass and moles of atoms or molecules or ion and vice versa. So the following are the conversion factors. So we have 1 mole of X per molar mass of X and 1 mole of X per 6.02 times 10 raised to 23 X of the atoms or molecules. So X class now represents the symbol of atoms, ions of the formula of the compound. So nakita na natin kanina yung application for the molar mass. Paano natin ginagamit si molar mass in computing the mole and the mass? So we used the molar mass as a conversion factor, like what we have seen a while ago. Now, in this part, we're going to see naman how Avogadro's number is used as a conversion factor in computing naman the amount of the particles present. Like, for example, atoms or molecules. Okay, so let's find out how Avogadro's number is applied in this computation. So we have here an example. Sample problem number 1. How many atoms are there in 16.5 grams of zinc? Pinapahanap sa atin kung gaano karami yung atoms. No, take note class, 'di ba? Si atoms, ions, molecules, these are the particles, na present sa isang compound, sa isang molecule. So ngayon pinapahanap ito sa atin. Para mahanap ito, ay kailangan nga natin gamitin o i-apply si Avogadro's number. Bakit? Kasi nga po 'di ba, si Avogadro's number, siya yung value, equivalent value ng amount ng substance natin, Yung amount ng substance natin is equivalent to the Avogadro's number of particles, which is 6.02 times 10 raised to 23. So now, since we're asked to find how many atoms are there in a 16.5 grams of zinc, dito natin siya ngayon i-apply. So with the given mass of zinc, 16.5, we are asked to find the number of atoms of the zinc. So the solution here is we're going to use the Avogadro's number. Okay, so again, di ba, si Avogadro's number, siya yung nagre-represent ng atoms or molecules present, no, on our element, compound, no, or ionic compound man siya or molecular compound. Now, for this case, it's an element, so atoms yung hinahanap natin. So, of course, no, in order to find the atoms, how many atoms na present in this given value, we need to find, of course, the mole using the molar mass. Now, so the first thing that you're going to do is to find mole of 16.5 grams of zinc and then use the conversion factor for the Avogadro's number. So what I did here is, diniretso ko na yung computation. So we have the first part wherein the mass, no, is converted into mole using the molar mass. So we have 16.5 grams times for every 1 mole, we have 65.409 grams. Makakancel si grams, may iwan yung mole na value, which is ita-times natin sa conversion factor natin. Now, this conversion factor, reversible to. Pwedeng nasa ibabaw yung 1 mole, pwedeng nasa ibaba yung si Avogadro's number, and vice versa. For this case, no, kailangan natin yung atoms, no? Dami ng atoms na present. So, nasa ibaba yung 1 mole of zinc, no, per 6.02 times 10 raised to 23 atoms. So, ito yung equivalent niya na value in atoms. So, cancel si mole. So, the final answer, it's 1.52 times 10 raised to 23 atoms. Okay, so ibig sabihin, ganito karami yung atoms na present sa ating given value, no, na 6.5 grams of zinc. So, let's have another example. Sample problem number 2. How many molecules are there in 0.334 grams of ammonia? So, dito naman, class, no, molecules naman po ang pinapahanap sa atin. Okay, bakit kaya molecules? Kasi take note, class, ammonia is a molecular compound. Okay, if we go back, no, doon sa definition, no, ni Avogadro's number, kapag element, no, yung tinutukoy, atoms yung ating hinahanap. Okay, atoms yung present, no, in an element. Now, for the molecular compounds, no, molecules naman yung hinahanap. So, balik tayo dito. So, ito na nga po ang pinapahanap sa atin. Given yung mass ni ammonia, 0.334 grams, pinapahanap sa atin yung molecules ni ammonia. So, again, we're going to use the Avogadro's number. Okay, yung ating reference, uli, yung ating conversion factor formula. And then, of course, we need the molar mass. So, bakit uli may molar mass? Kasi kailangan hanapin yung mole para ma-convert siya into molecules. So, again, now, find mole of ammonia, then use conversion factor for the Avogadro's number. So, we have here, again, this one, the mass of ammonia, 0.334 grams, times the molar mass. Now, for every 1 mole, there's 17 grams. Cancel si grams. May iwan si mole. So, yung value ng mole, ita-times natin siya sa conversion factor natin for Avogadro's number. So, we're asked to find the molecules. Makakancel si mole. And the final answer, it's 1.18 times 10 raised to 22 molecules. So, again, ito po yung dami ng molecules, no, na present sa ating 0.334 grams of ammonia. So that's how we use, no, the conversion factors for Avogadro's number, no, in determining the number of atoms or molecules present in our given substance.